Hello geometry students, my name is Jami Emigh, and this video is our discussion on section 3.3, parallel lines and angles formed by transversals. All right, in the last section we looked at the theorem called the alternate interior angles theorem. And that was the theorem that said if you can find two alternate interior angles that are congruent, then you could say that the lines are parallel. Now this theorem here is the converse of that. And you're going to want to keep the two straight because when you're justifying a step in a proof, sometimes it'll be the alternate interior angles theorem, but sometimes it'll be the alternate interior angles converse of the theorem. All right, so this section is all the converses of the theorems we learned in the last section. So a little review on what a converse is. You take your if and whatever your hypothesis is, comma, then, and whatever your conclusion is. Okay, that's your conditional statement. The converse is where you take P and Q and you switch them. So it'd be if Q, comma, then P. Okay, so that's the converse of the theorem. And so this theorem right here is the converse of alternate interior angles theorem. There's the if, here's our Q, two parallel lines are cut by a transversal, comma, then we can say that alternate interior angles are congruent. Okay, here it is in symbols. If line L is parallel to line M, then we can conclude that angle 4 is congruent to angle 6 and angle 3 is congruent to angle 5 because these right here, 4 and 6, are alternate interior angles. 3 and 5 is another pair of alternate interior angles. Okay, let's look at it on the figure now. If these two lines are parallel, so that would be this geometric code right here, then we can add 4 is congruent to 6 and 3 is congruent to 5. Okay. All right, I'm going to erase all that and I'm just going to say it one different way. If you see a figure like this, where you have this geometric code, then you are able to add this geometric code. Justification, alternate interior angles converse. All right, finding angle measures. Using the figure shown and given that angle 3 equals 55 degrees, find the measure of each angle. Tell what theorem or postulate you use. Okay, so they've given us a piece of information here. I always like to put that onto my figure if reasonable to do so. It's going to be kind of tough to write it, but I'll write it anyways. It's 55 degrees right there for angle 3. So that's an acute angle of 55 degrees. All right, first one, they want, I also want you to notice this geometric code right there. They didn't state it up here. They didn't say given that the two lines are parallel, but the geometric code is there, those two arrows. So so those lines are parallel, regardless of them actually stating something like given line L is parallel to line M. Okay. All right, so that being said, we have two parallel lines and we know the measure of one angle. Angle 3 is 55 degrees. What do you think the measure of angle 5 is? Well, it might be helpful if you're struggling to determine how angle 5 is related to angle 3. Angle 5 and 3 are both on the interior of the parallel lines, and they're on alternating sides of the transversal, so they are alternate interior angles. And the last theorem said that if two lines are parallel lines are cut by a transversal, then alternate interior angles are congruent. That means that angle 3 and angle 5 are congruent. So if angle 3 is 55 degrees, then so is angle 5, 55 degrees. Justification, alternate interior angles converse. Okay, next angle they want, we're being requested to give the measure of is angle 7. What do you guys think measure of angle 7 is? If you said 55 degrees also, then you got it right. 7 is also single arch mark, 55 degrees. Justification, angle 5 and 7 are related by vertical angles, and we know that vertical angles are congruent. All right, the next angle we are to find the measure of is angle 4. Let's go ahead and take a look at angle 4. Try to see how it's related to the angles that we do know, 3, 5, and 7. Is it related to any of those? I see a linear pair right here. 3 and 4, see how they form a straight line? So there's the line. Here's the common side. Here's 3, and here's angle 4. So those have to add up to 180 degrees. Those are supplementary angles. So if you have to add to 180, then 180 less 55 would give us the measure of angle 4. (180 minus 55 is 125. Justification, linear pair theorem. Erase that scratch work. Okay, one more angle. Ooh, I erased all of our measures. We have 55, 55, 55, and now we have 125. All right, last one, angle 2. What do you guys think the measure of angle 2 is? If you said 125 degrees, you got it right. One justification would be that it's vertical angles with angle 4. So the vertical angles theorem says that those two angles are congruent. Let me sketch them over here if you're not seeing how they're vertical angles. 4 and 2, anytime two lines cross like that, you have vertical angles. So 4 and 2 are vertical angles. And the vertical angles theorem says that those are congruent. So whenever you see two lines crossing, you can always add congruent markings like this. Justification, vertical angles are congruent. All right, we weren't requested to find the measures of any of the other angles, but knowing just one of the measures will lead us to all of them. If the two lines are in fact parallel, so if this is here, the two arrows, you only need to know one angle measure, the 55, to get to all the angle measures. Let me show you. If the two lines are parallel, 1, 2, and you can find angle 3, or if you're given angle 3, then you can find all the others, because 1 and 3 are vertical angles, so they're congruent. 3 and 5 are alternate interior angles, so they're congruent. 5 and 7 are vertical angles, so they're congruent. 8 and 7 are a linear pair, so that will tell you the measure of angle 8. And then 8 and 6 are vertical angles, so they're congruent. 3 and 4 are a linear pair, so that'll tell you the measure of angle 4. And then 2 and 4 are vertical angles, so that'll give you the measure of angle 2. So by knowing just one angle measure, you can find all 8, okay? And you're probably going to use that skill quite a few times, so look out for it. Last thing I want to point out is that all 8 of those angles, they only take on 2 different measurements. The 55, anywhere you see the single arch mark, and the 125, anywhere you see the double arch mark. It won't always be 55 and 125, but they'll always be just 2 values, and those 2 values add up to 180 always. Corresponding angles converse, okay? All the converses start with if the lines are already parallel. So if this geometric code is here, then you can conclude that the corresponding angles are congruent. So corresponding, anything in the same spot. So 1 and 5 are congruent. They're both red. 2 and 6 are in the same spot. Those are congruent angles. 4 and 8 are congruent. I'm going to use the triple arch mark right now, even though we know it's the same as 2 and 6 because they're vertical angles. And you can also say that 3 and 7, I'm going to go ahead and use the quadruple arch mark, even though we know that the single arch mark would have been just fine because they're vertical angles to 1 and 5. But I'm just trying to show these 4 statements with separate single arch mark. Then we did double, then triple, then quadruple for the geometric code. Same side interior angles, converse. Remember, the converses start with the parallel lines. All right, if our lines are parallel, so if we have these 2 arrows here, then same side interior angles are, and this time it's not congruent. This is the only time that they're supplementary. So same side interior. So this is the interior. 4 and 5 are on the same side of the transversal. 3 and 6 are on the same side of the transversal. So 4 and 5 have to add to 180, and 3 and 6 have to add to 180. Justification, same side interior angles, converse. Alternate in exterior angles, converse. Okay, so how do all the converses start? If you said with the parallel lines, you got it right. So if this geometric code is here, then alternate exterior angles are congruent. So alternate exterior, so opposite sides of the transversal and on the exterior. So 1 and 7, 2 and 8 would be congruent. 1 and 7, 2 and 8. Justification, alternate exterior angles, converse. All right, given the figure shown and one angle measure 4 equals 42 degrees, find the measures of the other angles. All right, pause this video now and try that. Welcome back. If you said that the measure of angle 2 is 42 degrees, you got it right. Justification, it's a vertical angle with 4. Measure of angle 6. If you said 42 degrees, you got it right. Justification, it's the alternate interior angle with angle 4, and alternate interior angles are congruent if our lines are parallel, which they are. So that would be the alternate interior angles theorem, converse. Measure of angle 8. If you put 42, nice job. You could have gone with corresponding angles converse, because it's corresponding with angle 4. Or you could have gone vertical angles with angle 6. Measure of angle 7. If you put 138 degrees, you got it right. Justification, well, it's a linear pair with angle 6 or linear pair with angle 8. Angle 5, 138 degrees is the correct answer. Justification, could have gone vertical angles theorem with angle 7 or same side interior angles with angle 4, converse. Angle 3 is 138. Justification could be alternate interior angles converse, or maybe a linear pair with angle 2, linear pair with angle 4. Oh, it's even corresponding with angle 7. So lots of ways to justify that one. And the last one, 138 degrees. You could go with vertical angles. You could go with supplementary to 2 and or 4. It's corresponding with 5. It's alternate exterior with 7. So lots of justifications when you get down to that last one. So again, notice that every angle is either 42 or 138. And that will always be the scenario when you have any two parallel lines cut by a transversal. And 42 and 138 add to 180. It's always a good way to quickly check your work. What are the measures of angle 3 and angle 4? Which theorem justifies each? All right, pause this video and please try to find the measures of angles 3 and 4. Welcome back. Check your own work. If you put that the measure of angle 3 is 105 degrees, you got it right. Nice job. All right, if you did not get that, let's try to figure out how we got that. Okay, so my advice to you is, given 4 lines, they've given you an extra one. There's one you don't need there to find angle 3. So I like to erase the one that I don't need, mentally or physically erase it. So I'm going to figure out which one I don't need. Okay, I have to use the 105 degree angle because that's the only known measurement up here. My goal is to find angle 3. So these are the 2 angles that I am interested in. So which line up here, and your options are line M, L, P, or Q, which line has nothing to do with the creation of this angle, 105, and this angle, angle 3. If you said line L, you are correct. Line L has nothing to do with those 2 angles. So I'm going to erase everything. And I'm just going to do your best to mentally not pay attention to that one. Okay, so now if you have to redraw it, that's fine. If you're using scratch paper, just redraw it on the side. Just a little sketch. We've got the 105 and the angle degrees, and angle 3 is our question mark. And then ask yourself, well, how are those 2 lines, which are parallel, so we know we're going to be using a converse of a theorem, how are those 2 angles related? And if you said alternate interior angles, you got it right. So that means that they are congruent by alternate interior angles converse. All right. Check your work for angle, or the measure of angle 4. If you put, what do we have here? Oh, it looks like we didn't subtract 105 from both sides. Oh, there we go. If you put 75 degrees, you got it right. So the answers were 105 and 75 degrees. Let me help you with angle 4 if you didn't get 75 degrees. I'm going to do the same thing. These are the 2 angles that I'm interested in, 1 and 2, the known one and the one I'm being asked to find. So the extra line in this problem is P. I'm going to erase it. I'm even going to go as far as just a quick sketch so that mentally I can just focus on angle 4 and on the 105 degree angle. And then I ask myself, how are those 2 angles related? And they are same side interior angles. And if the 2 lines are parallel, which they are, then same side interior angles are supplementary. So they have to add up to 180. So this angle 4 would have to be 75. And the justification would be same side interior angles converse. All right, using algebra and parallel lines theorems to find angle measures. Given the figure and line L being parallel to line M, I hope when you guys read that right there, or when you saw this right here, you think I've got to justify with converses of the theorems. Find the value of x. Okay, so we need to find a balance. We need to write an equation. Needs an equal sign because that's what makes an equation, and we want it to have an x in it. So look at your figure. How are these 2 angles related? It's like same side exterior angles. Same side exterior angles. Is there a theorem about that? Same side exterior. Let's go back. Same side exterior. There isn't. We've got, here's the start. We've got alternate interior. We've got corresponding. We've got same side interior. We've got alternate exterior. But no same side exterior. That's really the only theorem we don't have. These two, the relationship with these two angles. But that's okay. We still know that they're either congruent or supplementary, because anytime you have two lines cut by a transversal, the 8 angles formed, 1, 2, 3, 4, 5, 6, 7, 8, are either congruent or supplementary. So we know the answer is either 105 or 75, because that would be the supplement. So how are we going to figure it out? Well, looking for balance still. We know that 105 in this one here are vertical. You can mark that off. And then you know that angle 3 is corresponding to, I'm just going to call this one angle, I'll call it 1. Angle 3 and angle 1 are corresponding angles, so they're congruent. And angle 3 is a linear pair with x plus 30 degrees with that angle represented by that expression. So it's not congruent. It would be the double arch. Here would be a double, single, double, like that. So in our equation, we need to address that these two angles have to be supplementary. It means they have to add up to 180 degrees right here. So that's our equation. Ooh. This is our equation. Once everything's substituted in. 105 plus this one here equals 180 degrees. A little arithmetic or algebra work here, combining the 105 and the 30, combining like terms, and then subtraction property of equality, subtracting 135 from both sides of the equal sign, and we have x equals 45. That degrees symbol should not be there. Here we go. The value of x is 45 without the degree symbol. I don't like that that's there. Well, x many degrees. I can see why it's there, but at the end we say that the value of x is 45, no degree measure. And that will conclude our discussion for section 3.3. My name is Jami Emigh. Thank you for joining me, and I'll see you next time for our discussion on section 3.4.